Now, as we start Unit 3, it consists basically of Chapter 5 material, in which we're going to look at the greatest common factor. And we're going to look at Introduction to Factoring, as we mentioned earlier. So here we have a binomial that we're dividing by a monomial. Now the way you do that is you write the top part and model this with me. Now you take your common denominator and put it under each of these. And then simplify. So this is going to end up as a -1 here that we don't write. So just negative x. And then anything divided by itself is going to end up here. Negative divided by a negative is a positive 1. Now for number 2, they're asking us to take out the greatest common factor out of both. So the protocol for something like this is put a set of parentheses. We're going to have two terms inside. Then you look at the numerical part and say, what can I take out of both of these? Can I take a 6 out of both? No. Can I take a 3 out of both? Yes. Now you could take a positive 3, but this looks like you may want to take out a -3. Now there's no common variable, so the only thing you can take out of this is a -3. All right, let's see what you would get in here. Well, this would be a 7y plus 2x. Now, if you took out a positive 3 out of each one, probably should write that one too. It would just change the signs. Now, the key to all of this is if you factored out the greatest common factor, is that what is left inside the parenthesis, there's no more common factors. Okay, going on to number 3. Now, in our flipped classroom lesson, we talked about factoring by grouping. So here we look if we can take something out of our first two terms, and then something out of our last two terms. And we want to end up with common factors. So let me start you off on this one. Out of these first two terms, and you would put like a parenthesis, again, like we did up there, there's a p that you could take out of both. So here you'd be left with a p minus z. Now in the next set, and you say, well, I could take out a 6 out of both, but my signs are wrong. So again, the technique is if we take out a -6, that's going to reverse the signs. So this becomes p minus z. So now you have a common binomial factor in each of these terms in a sense. And what we would do then is put the p and the -6 in one set of parentheses, and then our common binomial in the other. Now, going back to chapter 4, when we said multiply this binomial in the traditional way, we said take the p and multiply it by this, which is what we have here. then take the -6 and multiply it by this. But here, we're not multiplying, we're factoring. This would be the end result. See, this would become this, and then this, if you multiplied through, would become this. But now we're factoring by grouping, where this now becomes this, and this now becomes this. Okay. Now, we'll let you work on number 4 by yourself. Now, in some cases, when you're asked to factor by grouping, you may have to rearrange things. That takes, again, a looking at it first, thinking what are you going to do, whether you have to move things around, and this one you don't. So you're going to factor something out of the first two and something out of the last two. Keep in mind that sometimes you might have to change signs. So something like this, out of these first two terms, you can factor out the x, and you're left with a minus 3b. And as you look at this carefully, you can factor out a 3y, and you're left with a minus 3b. So now your binomials are common factors in each of these. So you take the x, put it here, plus 3y, and then your common factor is a minus 3b. You have factored a 4-term polynomial by grouping. Okay, again, if you have any questions. Now, as you do these, you want to develop a protocol for working them. And as we look at example 5, they're saying this is the common factor they want you to take out of each of these two terms. So you've put that common factor out here, and you note there's going to be, they're taking out a negative, so that's going to change this sign. This term is going to end up as a positive, and this term is going to end up as a negative. So, give yourself some room. That's why we put a lot of space here. Write this and see what you can get for that. All right, something like this. Now again, always, especially on a test, check your work. Multiply this together by distribution. Do you get this? And then this by this. Do you get that? This would be a way to check. And notice within these parentheses, there's nothing common that you could factor out of this anymore. So then you're going to be pretty confident you have the correct answer. All right, let's go on to this next one, because they're giving us two terms, and you want to see what is the greatest common factor that you could take out of both of these. Now they're even, so you know you can take out a 2. They're in like groups of 10, so you can take out a 5. You can take out a 20. Yes, a 10 and a 20. But again, giving you some background, and write this over here too. 60 and 40. We're going to tease these apart. I'm putting them into their prime factors. Now, what are the common factors in both? Well, there's a 5 there. there's a 2 there and a 2 there, a 2 there and a 2 there. These are the common factors that are in both. So if we multiply these factors now, 2 times 2 is 4 times 5 is 20. So my answer for this, as far as the number goes, is 20. Now again, you could have seen that, but I see so many students will say 10 here, or 5, or 2. Again, you want the greatest common factor. Now, for the variable, that should be easy. Here, it would be x to the third, and here, you could take out x to the third. So the largest value of the variable you could take out of each term, that would then give you your greatest common factor. And that's what they've done up here, too. All right, we'll be working on some of these as we move on. All right, for number 7, see what is the greatest common factor you can take out of each of these 3 terms. Well, as you look, there is no number that's the greatest common factor except 1. So, can we take out a power of x? The greatest we can take out of each one is x to the second. And for the y to the second. That's all they're asking there. Now, for number 8, here's where you try, and you're going to put something out over here. Then you're going to have a parenthesis, and sketch this out here. And there's going to be 3 terms. So again, you're looking at it, and then you're going to fill this in. Take a moment, see what you get. Now, if this were a 6 instead of a 5, we could take a 2 out, but it's not. So there is no number factor common. And then as you did the letters, the greatest you could take out of each one is an X and a Y. And then you checked it. Now notice what's left within these parentheses. There are no more common factors. All right, for these last 2, what I'd like you to do is follow the protocol of dividing, in this case, a trinomial by a monomial. And the protocol would be to write out your numerator and then take your common denominator and put it under each one. And then you're going to simplify. Do the same thing here while we're here. Okay, and you're simplifying each of these as 3 separate terms. All right, take a moment. Now, as we look at these, again, there's a lot of skill here. A negative divided by a positive is going to give you a negative. And 21 goes into 42 twice. We're going to bring the 2 up, subtract it from the 4, and get x to the second. Now, 21 times 4 is 84. So this goes 4 times. 2 from 3 gives you a 1 that we don't write. Now, x to the second divided by x to the second is x to the 0, which is 1. A negative divided by a positive is a negative. 7 goes into 8 4 times, into 21 3 times. And this works in the same way. Let me pause, see if you have a question. Now, my final question to you is, as we look at this, is this a polynomial? Well, you might note that there's a variable in the denominator, so that would sort of eliminate it from being classified as a polynomial. But when we simplified it, there wasn't a variable anymore. So this would then be considered a polynomial, as would this one, for the same reasons. It's after you simplify. If there were still a variable in the denominator, then it would not be considered a polynomial. All right, we'll wrap this one up and get to our next topic shortly.